I got an easy job today. I have to introduce Jeff Smith. But I want to tell you my vision of Wichita. So what is, and I just answer, so you have to look at it a little bit different. And then part of this was from the BREG process. Okay, so we learned a lot from the BREG process of what is Wichita. And I want to talk about three things. First of all, what is Wichita? We're the air capital of the world, right? So we heard about that. But just think about why we're the air capital of the world. We make airplanes, but break it down even further than that. What do we really do really well in this town? We do advanced manufacturing. That's what we do. That's what the BREG process showed us. We do advanced manufacturing. So let me break that down a little bit further. We do advanced manufacturing. What kind of advanced manufacturing do we do? We do low volume, high precision parts. Low volume, high precision parts that are quite unique. So just think about what we do. We build low volume, high precision parts that defy gravity. That defy gravity. Just think about that for a minute, of the vision of what this community holds that I think we overlook. We build parts that defy gravity. Okay, and then we build parts that last. I'm doing aging aircraft work. We build parts that last 100 years. We don't know how far they last. We know, I mean, you go all the way back to the Wright brothers, but the parts that we build in Wichita are still lasting. And if you look at our military parts, they're going to have to last 100 years. So just think about that for a minute. Low volume, high precision parts defy gravity that last 100 years. That defines Wichita. That's what we do. So looking at how we can, and why is this guy talking about it, and why is he talking about healthcare? I'm going to tell you, and Jeff's going to tell you, that we have a possibility here. So if you think about that, so there is a technology that threatens Wichita, and it is real, and that is the additive manufacturing disruptive technology. But guess what? That will allow anybody to produce a low volume, high precision part. We need to pay attention. So one of the things I did in the Innovation Campus is, first thing, we've got to maintain the leadership in advanced manufacturing. I was lucky enough to meet Jeff Smith. A couple years ago I met him and we talked about this and said, we've got to leapfrog. We've got to leapfrog. We've got to maintain. So we're talking about diversity. Well, I'm talking about holding what we got. And can we do that? So then, luckily, Dr. Bardo came along and said, hey, we're going to build an innovation campus. John, can you do this? And let's talk about good things we can put on there. First thing, right off the list, I have got to maintain our leadership in advanced manufacturing. The low volume, high precision parts, and we have got to be the best in the world. So what are we doing right now? In town is the largest 3D printer in the world. Right here, we're constructing that, and it's a vision that Jeff and I had, and then we said, okay, well, golly, it's going to take $4 million to build this, and actually it's going to take more than that, but can we go find the money? Well, guess what? We presented a vision and we found the money. So it is real now. It's a real system. So that's number one. So number two, before I introduce Jeff, number two. Okay, now you know advanced manufacturing is special in Wichita. What is another thing that's special in Wichita? Is our engineering talent. If you look at the jobs that we lost in the economic downturn, the jobs that we lost, very few engineering jobs did we lose. How special is Wichita? Per capita, we are the number 3 place in the United States, behind San Jose and Houston for the number of engineers. Probably didn't know that, but we have a lot of engineering brain power here. So can we turn that to another industry? That's what we're going to talk about today. Can we turn that to another industry? So another particular thing, and why. So when I looked at the Innovation Campus, Dr. Bardo, and it says, well, what kind of partners do we need? I mean, there was one other aspect that came in, is our engineering, is what is the base language that we're all talking? The base language that all engineers in town, all the manufacturing shops talk. And actually it leads all the way back to one company, and that's why we brought him here, is Dassault Systems. We are one of the largest per capita users of Dassault System products in this town. Probably didn't know that either. In the world. Not in the United States, in the world. And that's why I said strategic partners, strategic allies. I've got to have Dassault Systems. So that's when we went out and we said, can we make this partnership happen? And I was lucky enough to meet, he's kind of my doppelganger. I mean, so I mean, you get him and I together, it's dangerous. I mean, because anything can happen. So I met Jeff, and he helped bring Dassault Systems here. It is their North American Center for Innovation, right here in Wichita. Okay, so then we said, okay, I said, number one, we're threatened by 3D, the 3D additive manufacturing printing. So people think, hey, I can just print anything. Well, you can't. You got to have a file. You got to tell it what to print, right? Well, Dassault Systems makes the background platform for that. Well, then I said, okay, how can I educate more and more people? How can I get that into a college curriculum? Well, we're having problems doing that, fitting it in. And so then we're working with WATC of how to get that in. And then I realized we got to push it lower than that. So 2 years ago, I started pushing CATIA, Dassault Systems products, down in the high schools. And I was amazed, absolutely amazed at what an 11th grader and 12th grader can do when you put a $25,000 per seat package behind them. It's a different type of future. Okay, so that is that second pillar. So the second pillar also has simulation. You're going to hear a lot about simulation. Well, that's what what does an engineer do? Break it down, all the way down to the root. They simulate. They design and they simulate in order to make the product the first time and it work and last 100 years. So that's what an engineer does. Simulate, design, and then build. Okay, so one of the things we did also is I've got to have a simulation center here that rivals anywhere in the world, and that is on campus right now. I mean, those of you who watch Star Trek, it's the closest thing to the holodeck you'll see. So you walk in it and you immerse yourself into an environment. Why is that so important? Because I need to simulate things, and you'll see the vision of where we're going to go. Okay, so that is pieces. So these are pieces that a lot of people don't understand. They see the innovation campus and they go like, oh, that's just about people, it's just about relocating. But it's not. It's bigger than that because we're developing a hub system for this type of innovation to occur. Okay, number 3, the other pillar, that specialist community. We're the healthcare hub of this state. We are. We're the healthcare hub of the state. So can we use advanced manufacturing, the simulation technology and innovation that our engineers combined with healthcare and put together something that will wow the world and make us something different? So I'm going to stop there because you're going to see it, that what the possibilities are if we just all combine together and make this a reality. So then that's I'm going to introduce Jeff Smith. He's been 3 years with Dassault Systems, but also before that he was at Lockheed Martin. And he's one of the only people that intimidate me with PowerPoint. So he intimidates me with PowerPoint. So I'm going to let him take over. Jeff, go ahead.
All right. Thank you. So I'm a blessed man. I am blessed with a wonderful wife, 36 years, 5 children, and 8 grandchildren, and counting. And when I retired from Lockheed Martin, I was an executive there, and I looked around the world and the phone calls, and it's like, you can't retire, right? There's just too much opportunities out there. And so I was very lucky and fortunate. I got to write my perfect job description and shop it out. And I decided to go with Dassault Systems, so I consult with them, work with them. And my life is about shaping a better world. And I'm going to take you on a little journey here. And I work for a CEO who's all about sustainable innovation and harmonization of product, nature, and life. Okay? So here you have a car. We all drive cars. And when you think about the amount of investment that goes into developing a car, for example, and then the car crash scenario where they actually crash physical cars. And so we've had different VPs of different transportation companies to say, hey, is there a way to create a virtual car in a multi-physics rich environment that we can crash and correlate the two together so that we don't have to crash so many physical cars? And so we took that challenge, and here's the result. So this is a very rich multi-physics environment where we're taking a particular car and crashing that into the standard crash test and being able to show in this very rich multi-physics world real time what's happening to that car. And so a regulator who's very familiar with doing these physical crash tests, he can look at this and he can have the same type of experience with this virtual crash testing at any level within the product structure of that car, just as he is able to do with a real car. So now, if I can do virtual certification of a car or a plane or some other industrial equipment device, the question becomes, if we provided doctors with the same incredible realistic simulation that we do in the car business, in the aerospace business, or any other industry, and we've been doing this for many, many years, what if we looked internally to the human? Could we do some incredible things there? And could we do this? Could we actually simulate, using these rich technologies, a living heart? So why simulate the heart? Why simulate the heart? Any thoughts? Number one cause of death, okay? Number one cause of death, a significant amount of money is invested in trying to resolve cardiovascular disease. And so we decided to take the challenge and see if we could actually simulate the human heart leveraging our rich technologies. So we started with the basics. Could we actually create that muscle tissue? And so we used our technologies to actually create that muscular tissue of a heart. And then we needed to create that forcing function, both externally and internally, so to be able to create that beat, electrically, mechanically correct, and then be able to create the 4 chambers of the heart, and to be able to have it work correctly. And then we thought, okay, if we can do this, we need to get some bright minds together. So we got about 10 or 12 around the world, surgeons, doctors, clinics, and so on, and we prototyped the heart. And then it was like, okay, can we bring all the great minds together across the world and be able to take this baseline heart and build upon it, improve upon it, to create a baseline heart, your heart, my heart. And so we created the Living Heart Project. And so this is bringing researchers together, clinicians, different industries, different regulators, and to be able to create this very rich environment called the Living Heart Project. And when you think about the world, there's been a lot of study over many, many years on the heart. It's been fragmented, a little disjointed, and the goal was, could we bring that all together? And you can see the type of companies, industries, research, and so on that are involved in this, and bring them together to be able to create the next iteration of the living heart. And from there, go on to other organs until we finally reach the point where you and I have our digital or virtual twin. So that team has been working for the last year to be able to take those original models and improve upon them, both from a mechanical perspective as well as an electrical perspective, to be able to create this baseline heart. We can also, when you think about what John was talking about from an additive manufacturing standpoint, we can also leverage biomaterials to be able to actually print organs. And this is just an example of a human kidney. So the possibilities are endless, what we can do with these rich technologies and being able to bring them together into an area like Wichita where the future can be made real. And we can be part of it. And we can experience the opportunity to see the next generation of what the human being looks like in the virtual world. So you've got the Innovation Campus. And I think everybody is familiar with this. What I'm so excited about from a Dassault Systèmes standpoint is that this Innovation Campus gives us the opportunity to bring multiple industries together and create a very rich learning by experiencing model. And why not a life science partnership, on the Innovation Campus itself? So you've got the Innovation Building. I call it the Innovation Center instead of the, I can't even say it, experiential engineering, but I like the Innovation Center. And when you think about the 25 different labs, I mean, you look at that shopping list, and there's this rich blend between what we see in industries like aerospace, as well as what we see from a life science perspective. So it's going to be a rich playground for us to invent the future. And this is what John was talking about. This is our 3D Experience Center, where on the right, we can create this very rich, immersive environment. So we can do the virtual creation of the product, even a human, and the associated processes before the physical creation. And then in the middle, we have our MRAM, which is our multi-robotic advanced manufacturing. It's our scalable, flexible factory. And then on the left, we have our reverse engineering capabilities, where we can scan virtually anything, including ourselves. And then on the left, the ability to be able to do conventional additive manufacturing, both from a polymer, as well as from a metal, as well as the new engineered materials of the future that we can design. So let's partner to innovate here on this wonderful campus to be able to create from the virtual world to the real world and be able to demonstrate it at WSU. So, a question. Will your virtual twin save your life one day? So together, let's build our health innovation ecosystem. Thank you.